Question here is to find the smallest number which when increased by 17 is exactly divisible by 520 and 468. For this thing that it is exactly divisible when increased by 17. So ignoring that, we can say we have to look for a smallest number which is exactly divisible by these two numbers. So therefore we are going to find the LCM of this, the lowest common multiple in this case. So we are going to use prime factorization method here for finding the LCM. So if I begin with the first number, that is 520, so it's divisible by 2 two times, 260 times. This is divisible by 2 again, 130 times, 265 times, with 5 13 times, and 13 one times. Now if I take the other number over here, the other number is what? This is 468. So with 2, this is 2 2 times, 2 3 times, 2 4 times. With 2 again, this is 1 7 times. With 3 39 times, and 3 13 times, 13 one time. Now if I write them in the product of prime, this is 2 raised to the power 3 into 5, 13. And then this is 468 is what? 2 raised to the power 2 into 3 raised to the power 2 into 13. Now for finding the LCM, clearly we are going to take the one with the highest prime, highest power with the prime 2 raised to the power 3, and this is 3 square into 5 into 13. So its product comes out to be what? We have 8 multiplied by 9 multiplied by 5 multiplied by 13, right? This is 13. So that results to give you how much? This is going to be 4680. Now check, what is 4680? This is 4680 is one such number which is exactly divisible by these two numbers, right? But then we have to find a number which when increased by 17 is exactly divisible. One more time, this is one such number which is exactly divisible by these two, but we are looking for one such number which when increased by 17 should be exactly divisible. So can we write this equation as this? Now for getting x, what we are going to do is to subtract 17 from this. So if I subtract 17 from this, is going to be what? The x comes out to be 4663. So this is going to be our required number, which when increased by 17 is exactly divisible. In this question, we have to find the largest number which divides 70 and 125, leaving remainder 5 and 8 respectively is. Now in this question, you can, like the previous one here also, we can ignore the remainder. And if I read this part, that the largest such number which divides 70 and 125, then it is clearly going to be what? The HCF, right? HCF will be one such number leaving no remainder when dividing 70 or maybe 125. But as you can see, it is leaving 5 remainder. So we should uh, subtract 5 from 70, that is 65. And similarly, we are going to subtract 8 from here, right? So on subtracting 8 from this, why? Because it should leave no remainder, comes out to be 117. And now we are going to find the HCF of these. So the HCF of this using prime factorization. The first number is what? This is 65. This is divisible by 5, 13 times and 13 one time. Similarly, if I take the other number, that is 117, it's divisible by 3, 339 times, and 3 13 times, 13 one times. So clearly, if I see the HCF is what? Let's say if I write once again 65 as 5 into 13, and 117 can be written as 3 square into 13. So we have to look for a common factor and the highest common factor. Although 13 is the only common factor, so highest common factor is 13 only. So we'll say that the required number in this case is 13. So 13 is one such number or the largest number which divides 70 as well as 125, leaving 5 and 8. Question says Dudhnath has two vessels containing 720 ml and 405 ml of milk respectively. Milk from these containers is poured into glasses of equal capacity to their brim. What we have to find out is the minimum number of glasses that can be filled. So what we are going to do is say, let's say for example, I take two container. Let's say I take this being the first container. It's not container, it's a vessel over here. And the other whose capacity is 405. So this one is 720 ml and this is 405 ml. Now we first will find out the capacity of one such container, right, with maximum capacity that can divide both of them exact number of times. Whatever is the whatever is the whatever is the capacity of this glass into which it has to be emptied must be an exact divisor of 420 and 405. At the same time, you can see that we have to we have to minimize the number of glasses. So in order to minimize the number of glasses, we have to maximize the size of each glass. And in order to maximize this size, clearly it should be the capacity. We are talking about the capacity, not the number. So capacity of this small glass must be the exact divisor of this and this. And of highest capacity is what? The HCF. So we are going to find the HCF of these two numbers. So let's say if I find HCF first. So this is 360 times, 180 times, 90 times, 245 times, 315 times, 5 times, and 51 times. For the other number, which is 405, this is divisible by 3, so this is 3, 1, 3, 5 times, with 3 again. This is 45 times, with 3 again, 15 times, and 3, 5 times, 5, 1 times. Now let's say if I write them in the prime factors. So 720 as what? 2 raised to the power 4 into 3 raised to the power 2 into 5. And 405 is what? 3 raised to the power 4 into 5. Now check for finding the HCF. For HCF of this number is going to be what? There is no 2 as common. Among 3, 3 square is common, right? And among 5, 5 is common. So this is 9 into 5, that is 45. Now, the capacity of this small glass is how much? 45 ml. But then we have to find the number of glasses. We have to find the minimum number of glasses. Now, what we know that in order to empty this container into small glasses, we will need how much? 720 divided by 45. What I mean to say that the capacity of this tank is 720 and it has to be filled into these small glasses whose capacity of 45 ml each. So the numbers will be 720 divided by 45. Similarly, we have to empty this one also, and the number of such glasses needed to empty the second one is what? 405 divided by 45. So now we can say that the final answer should be what? 720 plus 405, whatever it comes, so that is 1125 divided by 45. So if I divide it by 45, what it results to give you? 25. So we'll say that the number of glasses is what we have to find out, will be minimum